I'm going to record this session, so I'll unmute y'all right now, but I might have to mute y'all if the feedback is a bit much. So again, we're doing this. So today we're going to start looking at something called the standard deviation. And you might have encountered that word on the homework, but again, don't worry about it. Now, it's relatively minor. Okay, so we'll start looking at that today. And then on Friday, rather Thursday, we'll use what we're going to learn today to do something called z-scores. And then next week on Monday, we'll have review, and then we'll have our final assessment at the end of next week. So just to give you guys an idea where we're headed, okay? So you look at this, you can kind of see that the 60s have the most frequent numbers. So that's the mode. So even if you just look at this, you can already see that there's more numbers below the 60s, right? So that means left skew. So we can already see the data is left skewed. Okay, I already have this on the board, so we'll go back here. Now, if we made a little quick bar graph or histogram of this, if we just wanted to get a visualization, notice that there's a bunch of numbers down here on the lower end, and the most amount would be in the 20s, which was 5. And then here on the upper end, right, there's a bunch of numbers, and the most amount there would be the 60s, of which there are 10. So notice 10 is 2 times 5, right? So we got a lower end with a height of 5 and an upper end with a height of 10. So we got something like that. Okay, again, here's the mode. So you can see this is still skewed left. Now, the problem with histograms, it depends upon your interval. So looking at the stems here, we're basically doing intervals of 10. And this is just a, a big picture kind of what we're looking at. All right. Now, why does this happen? Well, this could happen because really we got two groups that we're measuring in these numbers. There's a group of lower end that have similar characteristics. And there's an upper end that has similar characteristics, right? And so this might be like if we got a sample of fish. There's a group of younger fish. They're not going to weigh as much. And then there's a group of older fish. And apparently there's more older fish. And they weigh more. So that's why this is happening. All right, and that could be true. We talked about classes and if these are test scores. So that's why you get something like this. All right. Now, when you count how many numbers there are, again, I'm not going to spend a lot of time elaborating because I think at this point we kind of should know what we're doing. If not, ask a question. So we got 29 numbers. Okay, so n plus 1 divided by 2 and n plus 1 divided by 4. So this is 15. Now, another way to think about the quartiles, if you divide by 4, that's by dividing by 2 twice. So we're going to have another half of the 15. So that's another way you could do this. Divide by 2 and then divide by 2 again. Right? So that's how you can get these numbers. Okay, so in between the 7th and 8th number from the top or the lower end, and in between the 7th and 8th number from the bottom or the upper end, and then the 15th number. Okay? So in between the 7th and 8th would have been in between 23 and 27 from the lower end, and from the upper end, in between the two first 66s would have been in between the 7th and 8th, and the 15th number was 55. Okay, so this would have been 23 plus 27 divided by 2, which is 24, or 25 rather. And then if we're in between the two 66s, well, that's 66. Okay, so let's go ahead and do a box and whisker. All right, so the lower end of data was a 3. The upper end of data was a 72. The lower quartile was 25. the median was 55, and the upper quartile was 66. Ooh-wee, look at that. Okay, so we got our boxkin whiskers. And, okay, and so notice that the left box is much bigger than the right box. Not only that, but the left whisker is also much bigger than the right whisker. So this is indicating left skew, which we already knew. We looked at that earlier, right? More data below the 60s, more data to the left of the mode.
My class is at 11:30.
Okay, which again means the mean, we didn't really calculate the mean. We would have had to add all these 29 numbers and then divide by 29. That would take a little while, right? That's why we do this. It's a lot quicker. And we can tell it's less skewed. And we know the mean is going to be less than 55. So it's probably somewhere over here. Okay, everybody good with that? So we're going to look at the homework. And then today we're going to basically do calculations of the standard deviation. Okay. Go down here, let me check everybody out. All right, y'all, we got 2 more weeks. We can do this, okay? Now, you only had the odds, right? And so you can see that this would be the bar graph. And so this is kind of roughly symmetrical. It's not perfect. Looks like there's a little more to the right, right? So, and then here you can see the stem and leaf plot on the bottom. Let me zoom this up a little bit. Oh, I've got to click. All right. And so you can tell that there's more bars above the first 2. There's more numbers above the first 2. So there's 2 modes here. And it tells you down here that the stems are based on 10s. So if you were organizing these by 10s, there would be 2 modes. But either way, you can see there's more numbers greater than the 10s and 20s. And that would be true if you considered just the 10s as a mode, right? And so that's why it says that over here, skewed right. Now it says most of the data are on the first 2 stems, and that's true, but that's not necessarily why we call this skewed right. It's because there's more numbers to the right of the mode, right? So that'd be a better way of saying it than the way the book is saying it right here. Now 7, you probably were going to have trouble with because the way this is worded is not something that you're familiar with. Don't worry about it. And I'll explain what that means. Measures of center and variation. Okay, so we've done the mean and the median. Those are measures of center. Variation is how the data spreads out. Okay, so all we've really done to see how the data spreads out is by looking at boxkin whiskers and by measuring, you know, either side of the mode. That's all we've really done. Today we're going to look at the standard deviation, which is what they're referring to here. Okay, so if you have symmetrical data, then the mean is okay because it's going to be pretty close to the median. If you have skewed data, then you really want to use the median. That's basically all you need to know. If you have symmetrical or roughly symmetrical, like these 2, then the mean is going to be pretty close to the median, so it'll be okay. But if you have skewed data, like this number 8, it's a whole lot more bars to the left, you'd probably be better off using the median. Okay, so that's basically the idea when they're asking you best represents the data. All right, and then you can see here 9. Now this is also skewed, right? And this is heavy skew. Everything is on the right of the mode, nothing on the left of the mode. And so it'd be better for us to use the median. Okay? And then going down to these. So again, when you get to number 11, this is one I didn't really like the way it was worded. So people looked at this and said, okay, most of the data is on the right. Okay, so distribution skewed right. No. Look where the mode is. There's more data values, less to the left of the mode, so this is skewed left. All right, and the way the book's worded that says when most of the data are on the right. That's not really a good way to word that, okay? Because when you say on the right of what? These 3 bars are on the right. This little bar is on the right. It's a little bit vague, so I don't think that's a good idea to describe it that way because it will cause, I think, misunderstanding. So it's better to say which values of the mode, how many more are on the left, how many more are on the right. More data values on the left skewed. That's a better way to say it. All right, and then here 13. Well, if you're gonna represent data, making a histogram is a lot easier because then you can just do this little height of the bars. You don't have to account for the exactly numbers. You don't have to put all the numbers down. You can just do the height of the bars a lot quicker, a lot easier. Okay, and then 15, notice when you compare these, right, it looks like for town A, most of the data is in the 70s and 80s, whereas in town B, most of the data is in the 50s and 60s. So town A will, on average, have higher temperatures than town B. And if you look at town A, it's skewed left, more data values to the left of the mode, whereas town B, it could be skewed left, but both of these two are so close to each other. Town B is roughly symmetrical, again, because these two are so close to each other, and so to the left and to the right, those 2 bars are roughly the same. So this is somewhat symmetrical. Okay, again, that's what's difficult about using bar graphs. That's why we use box and whiskers, because this is a little bit ambiguous slightly. Right, and again, you can see what the book said. And then here, so if we have right skewed, you can think of that as heavy right skewed. Remember we looked at that with actresses and actors and who gets the big salaries. We looked at that at people in major leagues who steal bases. Most people don't steal, very few steal a lot. Well, same thing with salaries in a large company, like a big multinational corporation like Exxon, right? So they have a few people who make a lot of money, the CEOs, and then a whole lot of people tend to make lesser wages. So you'll get a lot of high bars in the lower end of the wage scale, and that'll gradually drop. And then the people who make the 10 million, 20, 30, 40, 500 millions, 1 or 2 of them on the far right. So again, it'll look like, where's that? Yeah, it'll look like this. Okay, so again, maybe this is stuff that you guys know. So here, when you were doing this problem 19, you can see that those are the 2 box and whiskers. Now, the problem with this one, what would have been C and D, y'all would not have been able to really do that because you're going to have to be able to do that by looking at the box and whiskers. We haven't learned a standard deviation yet. So again, don't worry about it, but I'll tell you what you could have done. If you're looking at C here, you got 730 and 1570. So that's freshmen. Well, 730 is right about at the left quartile, right? And 1570 is pretty close to the upper quartile. And we know we got 50% between lower and upper. So since that's, again, not precise, but we know at least half of the freshmen, probably more, but at least half are going to be in this range based upon box and whiskers. And the same thing with D, right? If you want 100 more, okay, well, that's basically a percentage, right? So find out where 310 and 1990 are. Well, 310 is a little bit more than the bottom here, and 1910 is right there, so you can't really get precise. You know it's going to be more than 50%, that's about it. All right, so the way they came up with these numbers is based upon something called the standard deviation, which you couldn't have done. Just wanted to point that out, no big deal. All right, and then here 21, if you double the data, that's just going to double the mean, and it's going to double the spread, but it'll still be symmetric. It's not going to change anything. It just widens the curve. All right, and then here, when 23, you had two different ways of making the histogram using these intervals, right? And so this is what you would have gotten. And so you notice with the going by intervals of 10 and going by intervals of 5. Intervals of 10, it looks symmetrical. Intervals of 5, it doesn't. It looks left skewed. All right, so that's what's tricky about histograms and boxing whiskers. Now, I did show y'all how to do this uniformly. You know, the max minus the min and divide by how many categories. That at least makes this fair. But it's still difficult to tell without boxing whiskers. So that's why we do that. Because boxing whiskers will confirm whether it's symmetrical or skewed. That way we don't have to rely on whatever particular bar graph intervals we're using. Okay, and then when you use more intervals, you get the spread of data a lot better. So that's why B, the spread's a lot more than the A. Yes, Bryce, but just keep in mind, we don't have too much longer. I'm sorry if I'm asking you a question a little late. I just saw it. All right, so just get it to me, but at some point, you know. All right, y'all, so hope I'm not boring you to death. Can't imagine what you guys are dealing with. So we're going to do what's called the standard deviation. And normally this would be a piece of paper I give you. All right, so I know you can read, but just to elaborate, where we've gone with statistics so far is we've organized data into intervals, we did frequency tables, we made histogram representations, we did the cumulative and the relative frequencies of how each interval occurs, how frequent. We started analyzing the median and the quartiles and made box and whiskers. And we really only did the mean in the beginning, right? So we really only dealt with the actual value when we calculated the mean, the average. And when we're just ordering the numbers and finding out the spread based upon position, right? Well, today we're going to look at how we do the spread based upon value. That's called the standard deviation. What you got to do is you got to find the mean. So we're going to add these numbers and divide by how many there are. They're 8. And then we want to kind of get an idea. On average, how far are these numbers from the mean? That's basically what we're going to do. On average, how far are these numbers from the mean? Okay, and this is how we do that. Okay, so I know you guys might be able to figure this out, but while I write this down on the board, what you're going to do is you're going to subtract the data values from the mean, then you're going to square that, and then in this third column, you'll have a whole bunch of positive numbers. You add those positive numbers together, you divide by 8. That's going to be the end of step 3. And then step 4, take the square root. So if you think you can follow it, go for it. Meanwhile, I'm going to write that on the board. Okay, did anybody get the mean? Anybody get the average of the 8 numbers, the mean? Correctamundo. The mean is 14. Okay, so we're going to subtract each data value from the mean. Okay, so 2 minus 14, 2 minus 6 minus 14, 8 minus 14, okay, so forth. And then at the end, you're going to end up with 26 minus 14. Okay, so I'm going to switch this to the back here. All right, so this is what you should get. So sometimes you're going to get negatives because the 2 is less than the mean. And then once you get to 16, now the data values are greater than the mean. Okay, and so you get these blue numbers. Now we want to square those. Okay, and again, we want to square them because we want to make them all positive. Okay, so these are the numbers in the third column. They're all positive. Now what you want to do is you want to find the sum of the numbers in the third column. Divide by 8. Did anybody get that? Anybody get the sum, or anybody get the sum and then divided by 8? Okay, so you're adding 144, 64, 36, 44, so 4, 4, 36, 64, 128, 144 rather. Anybody get that? Mm, 57.5, no, there's a miscalculation somewhere. All right, anybody? I'll write it down in a minute. Okay, so you should get 496. And then when you divide by 8, you get 62. Well, that's called variance. All right, that's basically the average of the squared deviations. Okay, that's what these numbers are called over here. These are called deviations. Right, some of them are negative, some of them are positive. These are the squared deviations. And so the variance is the average of the squared deviations. Okay, now because we squared these numbers, so that way we get nothing but positives, we originally wanted to represent the average deviation from the mean with the original numbers, so we compensate by taking the square root. So we want to basically undo the fact that we had to square them to get positive numbers. Okay, so then you get the square root of 62, which is 7.874. And that's called the standard deviation. Okay, and that's basically the average deviation from the mean. In these 8 numbers, on average, the deviation from the mean was about 7.874. Now, I'm using that word average. It's not really kind of exactly what's going on, but so what? That's basically what that means. Now, if you look at the blue numbers, we squared these so that we could get all positive numbers. What would have happened if you added all these numbers? What would you have gotten if you added these blue numbers? Anybody see that? If you add these blue numbers, bingo, bingo. So if we would have not squared them, we would have had 0 divided by 8. That doesn't help us. What, the average deviation from the mean is 0? That's the problem. That's why we're going to square these, because the issue with the negative numbers. I'm going to tell you in a second, Ryan. Okay, so now the real world significance, Ryan, is we can use a sample of data to construct the mean and the standard deviation and use that to create intervals within which we can have like 95%, 99.7%, and 68%. Okay, well, when we meet on Thursday, I'm gonna, you guys are gonna experience how we use this in the real world. Can't do it today though. But if you want to know, that's what we use it for. We use it to take a sample of data and extrapolate from that sample of data something that we can assume about the larger population based upon how much in the larger population would occur within certain intervals. And we use the mean and the standard deviation to do that. So like say you got a sample of fish, right? And you found the mean and the standard deviation. Well, from that sample, using the mean and the standard deviation, we can say 95% of the fish in this pond are going to weigh between 20 and 35 pounds. That's basically what we use it for. You can look it up if you want. Statistics, look it up. I'm sure there's a whole lot of stuff out there, but we'll get into that on Thursday. Okay, let me double check. I think that's about all I got for y'all. Yeah, that's about all I got for y'all. So the homework is, I think it's just 5 problems, and you're just going to be doing this. So, there's no need to do a whole lot of this for practice. Okay? Anybody need anything? Y'all good? Okay, I'm going to go ahead and get out of here. Y'all have a nice day. Yeah, you too, Zach.